find the key features of the function and give exact answers and round to the nearest tenth if necessary. So here we're going to find 6 features. Let's begin with the concavity. And the concavity is determined by the a value. If a is positive, then we have concave up. If a is negative, then we have concave down. Here the a value is 4. So actually let me go ahead and identify all of these. So the a value is 4, that's positive 4. We have concave up. Okay, now for the y-intercept, we have to substitute 0 for x, and then we'll have the outcome 0c. 0c. So here, we're going to have 0, and then the c term is negative 7. So this is the y-intercept, 0, negative 7, or if you're just identifying the y value, negative 7. Next, to get the x-intercepts, I have to substitute 0 for y, and then I have to solve either using the quadratic formula, completing the square, or by factoring. So here we have 0 equal to 4x squared plus 4x minus 7, and my choice is going to be to use the quadratic formula. So since I've already identified the a value, the b value, and the c value, I'm going to plug them in. So I get that x is equal to negative b, which is 4 here, plus or minus the square root of b squared minus 4 multiplied by the a value and the c value, so 4 and negative 7. That's going to be divided, or everything is going to get divided by 2 multiplied by a, so 2 times 4. I'll begin to evaluate, so I get x equal to negative 4 plus or minus the square root and then 4 squared. That's going to be 16. And then here we have negative 4 times 4, which is negative 16. But then a negative 16 times a negative 7 is going to change this to plus, and then we have 112. That's going to get divided by 2 times 4, which is 8. So here we get that x is equal to negative 4 plus or minus square root of 128. And then I'm going to want to simplify the radical here. So I'm going to get the prime factorization of 128. So here I can break this down to 64 times 2. And then the 64 is the same thing as 8 times 8. And then here we get 4 times 2. And here we get 2, 2, and 2, 2. So I have all of the prime factors now. So I can rewrite this evaluation as x equal to negative 4 plus or minus. And again, since we're taking the square root, I want to get pairs. I cancel out one pair there, so I have 1, 2 outside of the radical. I get rid of this pair, so I get another 2. And I have this pair as well. So I have another 2 outside of the radical. The only thing that gets to stay inside is this 2 that wasn't able to get paired with anything. So now I'll write this right here. I have x equal to negative 4 plus or minus 2 times 2 times 2 is going to give me 8. And then we have root 2 all over 8. The 4 and the 8, they have a greatest common factor of 4, so I'll factor that out, leaving me with a 4, negative 1 plus or minus 2 radical 2 all over 8. And then the 4 over 8 is the same thing as 1/2, so I can reduce that. And my solution is going to be x equal to negative 1 plus or minus 2 root 2 all over 2. And those would be the exact solutions of my x-intercepts. I'm also interested in getting the approximations. And for that, I'm going to write my x-intercepts individually. And to get the approximations, I'll use a calculator. And I've already done this. The results are negative 1.91 and 0.91. Okay, moving on to the axis of symmetry, we have to calculate negative b over 2a. So for our specific example, we get negative 4, since 4 is the b term. And we're going to divide that by 2 multiplied by a. Our a value in this case also is 4. So here we get negative 4, and then 2 times 4 is 8. And 4 over 8 can reduce to 1/2. So we have negative 1/2 as our axis of symmetry. To get the vertex, we're now going to plug in the axis of symmetry into the equation. Everywhere I see an x, I'm going to replace it by a negative 1/2. Now, because the negative 1/2 is actually a nice fraction, so to speak, I'm going to keep it in fraction form. So here I get that y is equal to 4 multiplied by negative 1/2 squared plus 4 times negative 1/2. And we're going to subtract 7. Now, negative 1/2 squared, that's the same thing as 1 over 4. And then here, 4 multiplied by negative 1/2, we're going to get negative 2. And then we have minus 7. Here, the 4 times 1/4 is just going to give me a 1. So we have to evaluate 1 minus 2 minus 7. 1 minus 2 is negative 1. And then if we subtract 7, we're going to get negative 8. So our vertex is going to be the axis of symmetry, which is negative 1/2. And what we just evaluate for y, so negative 8.